Hey guys, welcome back for another problem in our LeetCode 75 study plan series. So today we are moving on to a new category, the binary tree depth first search. So our problem today is called maximum depth of a binary tree. Given the root of a binary tree, return its maximum depth. A binary tree's maximum depth is number of nodes along the longest path from the root node down to the farthest leaf node. So the minimum knowledge required for this exercise is that you are aware of what a binary tree is and what depth first search is. So if you're not familiar with those concepts, I'll go ahead and leave a link in the description below for a couple of resources that can help educate you so that you're ready to tackle this problem. Trust me, it's really not that hard to understand, so you should be good to go in little time. So anyways, to get back to this problem, essentially we just need to, so for this problem right here, right, it is represented by this illustration right here. It's going to return 3 because 3 is the longest depth. We have 1, 2, 3, right? Or 1, 2, 3. It's pretty straightforward. So essentially, what we need to do is check our constraints real quick. So the number of nodes in each tree is within the range 0 to 10 to the 4th power. And then this is the values for our node values. Since it's 0 right here, our node can technically be null. So we might be given a null, so we have to create an edge case to account for that. So in order to do that, let's just set up an if statement. If root is equal to null, then we're going to return 0 because 0 is going to be our count if the root is null. Else, we're going to want to find the depth of the left and the right side and return that. So what we need to do is call the function recursively to check. We can do left depth, or first we need to call it an int, right? Because we're returning an int. So left depth, sorry, it's a little hard to say, is equal to, and then we're just going to call the function, and then we're going to put in root right here. Okay, and then I forgot, we want to put root.left, right? So if you look right here, this is the definition for the binary tree node, and we can access left and right values. Unlike a linked list with just one pointer, we have a pointer to the left and a pointer to the right. So now we want to do the same thing essentially, but for the right side. So right depth equals max depth root.right. Cool. And then now all we need to do is compare these two, so we can use the integer.mat or the math.max library that we've used before, right? Basically, we're going to return the math.max, and then we're going to compare the two, right? So left depth with the right depth, and it's going to return the bigger value of the two. But we also want to add 1. And the reason we want to add 1 is because it's not accounting for the root node, and we want to make sure that that's accounted for when we're returning our count number, our total count number. So let's go ahead and run this. Awesome. All right, so we passed the first 2 test cases, so let's go ahead and submit. Cool. All right, so we were successful in passing all the test cases. So now to analyze the time and the space complexity. So for the time complexity, it's going to be big O of n because it's going to traverse through the entire tree of size n. And then for the space complexity, it's going to be worst case big O of n, because say we have an unbalanced tree and it's skewed to one side, then it could be all the way up to size n. But best case, it's going to be big O of h, with h representing the height of the tree. Because remember that we're recursively calling the max depth function, so the call stack can be the size of h, and then worst case size of n. So that would be for our time complexity. So there you have it. I hope that this explanation and this walkthrough for this problem was helpful to you. If it was, please go ahead and leave a like and subscribe for more related content. And if you have any suggestions, please feel free to leave those in the comments. So we'll see you in the next video. Thank you.